So in this video, we learn about some important forms of frequency distribution. In the previous video, we already learned about the construction of a frequency distribution by taking a suitable class interval. So these are the important forms of frequency distribution, or we can say the variation of frequency distribution. So here we have a raw data by which we will make a frequency distribution, a simple frequency distribution, and by one I will construct all this frequency distribution by this raw data. So here we can see a simple frequency distribution is given here of this raw data. We already know how to construct this frequency distribution. Now let us learn about the relative frequency distribution for this raw data. So here it is. We have a relative frequency distribution tabular form for this raw data, and for this raw data, if we want to construct a relative frequency distribution, so what we have to do, we have to do nothing but we have to add another column in this frequency distribution tabular form, and another column is relative frequency, and another column is relative frequency. So how to find out a relative frequency? Relative frequency can be found easily by a formula, that is relative frequency is equals to Fi. That means individual frequency divided by the total number of frequencies, that is summation of Fi. So here, if we want to find out a relative frequency of 5, then we have to divide 5 by 23. So by using calculator, we can find this easily. So here we have a calculator and we have to divide 5 by 23. So 5 by 23 is equals to 0.21. So here you can see the result is 0.21. So let us write down it here. So by doing this process continuously, we will get 7 by 23 is equals to 0.30. 3 divided by 23 is equals to 0.13, and 8 divided by 23 is equals to 0.34. And these are the relative frequencies of this individual frequency. So here it is the relative frequency distribution of a raw data, and here is the raw data you see. So if we just add the percentage of this relative frequency, then the frequency distribution will become a percentage frequency distribution. So how can we find out the percentage? So we have to multiply 100 with the relative frequency. We have to multiply 100 with the relative frequency. So let's do it. 0.21 into 100 is equals to 21. So the percentage of 5 is 21. So by doing this process continuously, we'll get 30, 13 and 34. So here is the percentage of this individual frequency. So this frequency distribution became a percentage frequency distribution. Percentage frequency distribution. So in the important forms of frequency distribution, we learned about relative frequency distribution and percentage frequency distribution. Now we'll discuss about the cumulative frequency distribution. And what is a cumulative frequency distribution? So here, the cumulative frequency distribution is nothing but a representative frequency distribution which represents the sum of a class and all classes below it. And to be more exact, it deals with frequency by accumulation. So here we have an example for the same data, for the raw data, and the cumulative frequency is the summation of frequency of the class and all the classes below it. So let us have a look here. The cumulative frequency of this group is only 5 because there is no other classes below of this group or of this class. So let us look the next group. In this group we have cumulative frequency 12 because the frequency of this group is 7, and this group has only a group which is below of it, and the frequency of this group is 5, and the summation of 7 and 5 is 12. So 12 is the cumulative frequency of this group, and by doing this process continuously, we will get all the cumulative frequency. So by adding an extra group of cumulative frequency in the frequency distribution tabular form, we will have a cumulative frequency distribution. If the frequency distribution table represented by inclusive method, then we cannot make any cumulative frequency from it. So what we have to do to make a cumulative frequency, we have to make this inclusive frequency distribution to exclusive frequency distribution. And how can we make exclusive frequency distribution? As we know, the exclusive frequency distribution have the equal portion in the upper limit of a group and in the lower limit of its next group. That means the upper limit of a group is equals to the lower limit of its next group. That means here these two components should be equal. So how can we make this equal? By adding or subtracting something from this. If we add 0.5 from 29 and if we subtract 0.5 from 30, then this will be equal. So here this procedure will do for all this data of this group or class. So this is called class boundaries. And by adding 0.5 with 29, it will be 29.5, and by subtracting 0.5 from 20, it will be 19.5. Then the class boundaries will be 19.5 to 29.5, and this will be 29.5 to 39.5, 39.5 to 49.5, and 49.5 to 59.5. What we have done, we made this frequency distribution exclusive from inclusive, and now we can write down the cumulative frequency here easily. So the cumulative frequency for this group is 5, and this group is 12, and 15, and 23. So as you can see, there are no changes in the cumulative frequencies. Here you can see 5, 12, 15, and 23, and the same is here. So why we need to make this frequency distribution exclusive? Because the cumulative frequency represent how many variable values are occurring below of this value. If we say that 5 variable values are occurring below 29, it may be wrong, because these 5 values, maybe any one is 29. It can be happen, but by doing exclusive, no data can be 29.5. So we can easily say that all the data or all the frequencies are below 29.5. So the basic definition of cumulative frequency will not be hampered. So here let's get back to two types of cumulative frequency distribution. So from this cumulative frequency distribution, we can see that 5 values are occurring below 30. That means less than 30. 5 frequencies are less than 30. So let's write down here less than 30 and less than 40. And for this group, it will be less than 50. And the last one is less than 60. So how many frequencies are occurring less than 30? It will be 5. And less than 40 is 12, less than 50 is 15, and less than 60 is 23. And we can also put the percentage of this frequency if we want. So how can we find out the percentage? We can divide the individual frequency or cumulative frequency by the total number of observation and multiply this with 100. That means percentage is equals to effort divided by summation of effort into 100. So it will be 5 by 23 into 100. By using calculator, we can measure it easily, and it will be 5 divided by 23 into 100, and that is 21.73. And 12 by 23 into 100, it will be 52.17. And 15 by 23 is equals to 0.65 into 100, it will be 6.52. That means I made a mistake, and it will be 6.52. I forgot to multiply 100. And 23 divided by 23 is equals to 1, and 100 is equals to obviously 100. And these are the percentage of this cumulative frequency. And this type is obviously less than type, because we are representing the cumulative frequency of the less than in the less than quantity. So this is less than cumulative frequency. So let's look here. Here we have decumulative frequency distribution. That means 23 values are occurring more than 20, and 18 values are occurring more than 30. That means here it's presenting more than values, that how many values are occurring more than a single data. So if we represent these values, then we have to write more than. Here more than 20, more than, here the lower limit is 30, and here more than 40, and last more than 50. And we can see that 23 values are occurring more than 20. That means the frequency will be 23. And this will be same as decumulative frequency. That means we are presenting more decumulative frequencies in more than type, and we are presenting cumulative frequencies in less than type. So you can see for this data it is more than type and it is less than type. So we have understand that two types of cumulative frequency distribution, that are more than type and less than type. We have learned about cumulative frequency distribution. Let's discuss univariate frequency distribution and bivariate frequency distribution. Univariate frequency distribution is a distribution of one variable, and bivariate frequency distribution is distribution of data of two variables. This is a frequency distribution of a single variable. Suppose this is the data of daily expenditure of a kid. This is the data of daily expenditure of a kid. So the only variable is daily expenditure. So there is no other variables except it. Let us look at this. Here we are presenting a bivariate frequency distribution. That is, data classified on basis of two variables. And bivariate frequency distribution aims to determine empirical relationship between two values of two categories. So here you can see we are making an empirical relationship between the gender and the smoking status. In this chart or in this diagram, you can see the number of male and female as well as the number of smoker and non-smoker. And you can see there are 10 male who is a smoker, and 2 male who is not a smoker, and 3 female who is a smoker, and 8 female who is non-smoker. That means in this diagram we can understand about the gender, which is a variable, as well as the smoking status, which is the another variable. To be more exact, we are presenting two variables in a frequency distribution. So it will be bivariate frequency distribution. So finally we have learned about relative frequency distribution, percentage frequency distribution, cumulative frequency distribution, univariate frequency distribution, and bivariate frequency distribution. Thank you so much, and our next video will about the graphical presentation of frequency distribution.